Hello, welcome to week 8. It is almost the last week of the whole school year. Pretty exciting. So we have 2 lessons this week and then a quiz. And so it's kind of a normal week. Then next week we'll review and have our last unit test. So let's get started. Lots to do. All right, so this week is very similar to last week, but we're going to be talking about a different topic slightly. Look at the title here. It says Intro to Multiple Dependent Events. Last week we talked about independent events, and this week we're talking about dependent events. We'll get into what that means in just a second, but we're still going to be using the multiplication rule of probability, which means that when things happen in a row, you multiply them together. So, slightly different topic, but really very, very similar to what we learned in last week's lessons. Okay, let's get started here. So the example we're going to start with and talk about at first is suppose you pick a soda out of the cooler. Picture to the right, there are 12 Sprites and 22 Cokes. What is the probability that you pick a Coke? So you're just finding one probability. Remember, to find the probability of something, just one event, you need to find the total number of possibilities. So we could have any of the 12 Sprites or any of the 22 Cokes. So that's a total of 34. And then you need to put what you're asking about on top. So it's asking what's the probability of getting a Coke. There are 22 Cokes, so 22 out of 34. And then, as always, we multiply by 100 to turn it into a percent. So on our calculator, we're going to put in 22 over 34, and then we're going to multiply by 100. So the probability that you reach into the cooler and you get a Coke is 64.71%. Remember, we always want to round to the nearest 100th, which is the second decimal place. All right, so that was simple enough, right? That's basic probability. Let's take it up a notch, and we're going to talk about the multiplication rule again. The next question says, what's the probability if you're going back to that same cooler and you're taking out a second cola or a second soda? So now we're going to use that strategy that we've talked about before, where we're setting it up. We know there's 2 things happening in a row, so I set myself up for success. What is the probability of getting 2 Cokes in a row? So here's how we break it down. The first Coke is the same as the probability would be if you just took one. Then, because we're talking about dependent events, that Coke is now gone, right? You drank it. It is gone. It is not in the cooler anymore. And so, how has your probability changed for your second event? That's why it's not independent, it is dependent. So the probabilities are going to change. So now one of those Cokes is gone. Like if we're looking at the picture, bye-bye, one of those is gone. So now there's only 21 Cokes left. And that means there are 33 total left, because once you take a Coke out, not only takes away from the Cokes, but it also takes away from the total number of sodas. So we're going to put this into our calculator here. I'm going to cheat and just put in this extra fraction. And so it's very similar to what we were doing before, but the only thing that has changed is that instead of getting to just write the same probability over and over again, kind of got to think about it a little bit. And actually, it's pretty easy to get the hang of it once you start to see this pattern. Remember, I always say this, but mathematics is noticing the patterns and then using those patterns to solve the bigger problems, right? Best mathematicians are lazy, so figure out what the pattern is and follow the pattern in a more quick and easier, efficient way. That's all that math is. All right, last little example here we'll do in this style, so hopefully we'll start to see the pattern here. You go back to the cooler again, and we want to know what's the probability that you get 3 Cokes in a row. So the first Coke, 3 things happening in a row. First of all, we want to set ourselves up for success, so we know we're multiplying 3 probabilities together, first, second, third. The first probability is still the same, right? There's still going to be 34 total and then 22 out of them are Cokes. Okay, then we took one of those out, and so notice how that is the exact same thing as we had over here. And then the third time, there is again 1 less Coke because you already had 2. So now I want to know what the probability is if I took 2 of these Cokes out of the cooler and I went back for a third. What would be the probability that the third one was also a Coke? And every time you take a Coke out, it changes the probability. So let's put that next probability in there, and we get 25.74% if you are rounding correctly. Okay, so now this is the same question as we had last week, but with flipping coins. How many Cokes would you have to try to pull out of the cooler before you get to 1% chance that you get a Coke? So I want you guys to maybe go back to your 7.2 assignment, take a look at it, and come back when you've thought about how many times would you have to go back before the probability was under 1%. Okay, hopefully thinking about this question helped you realize what the pattern is. And so if we keep going back to the cooler and getting another Coke and another Coke and another Coke, the number of Cokes is going to continue to go down by 1 every single time. And the total is going to continue to go down every single time. And so this is the big idea of the lesson, is that when we're talking about dependent events, the numbers go down by 1 every time. And you can see on my calculator, it took me quite a while to get below 1%. And I had to keep going down and multiply by 100 over here. Good practice, good calculator practice. And so you can see I got down to 14 over 26, and that finally put me over the edge with 0.95%, which is less than 1%. So pretty cool. I hope that helps you with the big idea that we have here, and we're going to define multiple dependent events now. All right, so our definition of multiple dependent events is events that happen in a row. So we already knew that. We're going to use the multiplication rule, where the first event changes the probability of the second event. And then that changes the probability of the third event, and the fourth and the fifth, and so on. And each time an event happens, or each time you take a Coke out of the cooler, is the example we started with, a object, item, person, it depends on the scenario, right? It depends on what the question is asking. Something is removed. And so that's an important thing to keep in mind, is that when we're dealing with dependent events, something is removed every single time. So my next question for you is there's no context here. There's no story, there's no scenario. But if you had set yourself up for success like this or like this, what would you fill those numbers in with? You don't know anything about this situation. but I bet you know how to fill in those blanks correctly by looking back up at the patterns we talked about with the cooler full of sodas. So give it a shot. See what you can do. All right, so hopefully you're feeling successful on that. Notice how all my numbers just go down by 1. Go down by 1. Same with this, go down by 1, go down by 1. And so I'm just hoping that you're starting to see the pattern, which is that if it's the same event happening over and over again, all the numbers just go down by 1, and you do it as many times as you have an event happening. So however many times in a row something is happening, that's how many fractions you have. All right, let's get started on our example. All right, so it says a teacher has 32 calculators and 8 of them are broken. So stop there. You can find your total, which is 32, right there. Now it's a little confusing because sometimes you have to add things together and sometimes you don't. So keep that in mind. It gives you the total number of calculators right there at the beginning. 8 of them are broken. You decided to be nice and grab 3 calculators. So there's your number of events. You have calculators. You have a total number of calculators. You're doing it 3 times. So there you go. What is the probability that all of them work? Now, it's a little bit of work, but not too much. If 8 of them are broken, then 32 minus 8, 32 minus 8 is how many are working or not broken. They could be working, but just be like slightly broken or something. All right, so 24 out of 32. That's the probability of getting 1. Now that 1 is gone, and you need to find the probability of getting a second one. All right, now that 1 is gone, and so we're going to try to find the probability of getting a third. And since we set ourselves up for success, and we already had all that figured out, that's it. That's all we got to do. So now we just put it in our calculator, 24 over 32 times 23 over 31 times 22 over 30. So all the numbers are going down by 1, and we get 40%, 40.81% chance that you get all 3 calculators that are working. All right, next one. A teacher has same exact scenario, right? But the only thing that has changed is that they do not work. You're still getting 3 calculators. So 1, 2, 3. Feel free to copy and paste to save yourself some time on this if you want. We know we're starting with 32. It's going to go down to 31 and then go down to 30. And 8 of them are broken, so we switched it up. We're no longer looking for working calculators. We're looking for the broken ones. All right, hold on just a second. All right, so there you have it. There is our answer. And go ahead and try that on your own and then come back and we'll do another example together. All right, so here's the setup for the next example. Slightly different because you have 3 groups. You have Democrats, Republicans, and Independents. So find the total would be equal to 100. So our first probability, no matter what the question is about, is going to be 100. And then that always goes down by 1 each time because we're dealing with a dependent situation. And we're going to select 3 senators. That's why I have it set up with 3 scenarios or 3 fractions. And then we want to know what is the probability that all 3 are Democrats. There's 48 to start with. Once that one's gone, you only have 47. And then you have 46. So I'm going to do this on my calculator real quick and be right back. There you go. There's the answer for you. So the next question is exactly the same question, but it's asking about Republicans. And you can see that the setup is exactly the same, but instead of starting with 48, we're going to start with 50, and then it goes 49, and then it goes 48. So you're putting that into your calculator. Go ahead and give it a shot and check your answer with me. And there it is. So we're at the end of our examples today. There's some challenge questions on the next page. Good luck, and remember, you can always come on Friday at noon in FJ Office 10 to go over all the red box questions with me. Good luck!